I want to talk about multi-statement table-valued functions because the primary driver of a multi-statement table-valued function is a table variable. We've talked about table variables once or twice so far, and because they are the primary driver of a multi-statement table-valued function, multi-statement table-valued functions inherit genetically a lot of the defects that table variables carry with them, I guess. So let's look at some of that. All right, look at some of that stuff. So what we're going to do is declare a simple table variable and insert some data into it, and then we will select data out of it. And the reason that I have this hint here will make a little bit more sense in the next demo, but for now, let's just rock and roll with this. So this should run for just about 4 seconds altogether. It's inserting the rows in and then selecting them out. And that's pretty simple there. Now, first thing that I want to make sure everyone is aware of is that modifications to table variables are forced to run serially. If we go hit F5, or sorry, if we either hit F4, not F5, we already hit F5 and ran the thing. If we hit F4 on the insert or on the root operator, or we get the properties, we'll have this non-parallel plan reason. We could not generate a valid parallel plan. This is true of any modification to a table variable, insert, update, or delete. And if you don't have a particularly big, complicated query inserting into a table variable, this probably doesn't matter much to you, but it is something that you should be aware of. And the other thing is that even though we just stuck, let's see, 1.3 million rows into this table variable, SQL Server only thought 1 was going to come out. So we get a very bad guess coming out of the table variable. However, at least we can read from that table variable in parallel. We see you have a parallel, little parallel icon there. If we go to properties and we look at the rows, we can see that across 4 threads we had some pretty decent row distribution there. So it is possible to read from a table variable in parallel. The problem is that quite often, because you get this very bad estimate here, right? You get this 1 row estimate. Oftentimes, the cost of the plan will be so low that you will not get a parallel plan. Here, I hinted the plan. I used a query hint to make this go parallel. Under normal circumstances, a query that costs 0.035 query bucks is not going to go parallel. Now, you do need to make one distinction here, and that's the cost of the parallel plan. We can look at the cost of the serial plan and see if it would be expensive enough to go parallel. Rerun this. I don't know how long this is going to take. It could be days or hours or minutes, seconds, but ooh la la, I was right. Because of this very low 1 row estimate, we get a very cheap serial plan, and SQL Server at no point even considers parallelism for this. This query would have to cost at least 50 query bucks. And if we had an honest guess here, I would be willing to bet that SQL Server would give us a parallel plan. And we can test that out by trying a recompile hint and see what happens. Using a recompile hint, we'll get table cardinality from the query, but we will not get any column level statistics. And lo and behold, when we use a recompile hint and SQL Server gives us an accurate estimate, then we get a parallel plan. Now, I know that number looks weird to you, but if you recall back to the other video in this series about bitmaps, then you'll recall why this estimate looks off. We have an in-row probe here, which means that we have the bitmap filter ruling rows out, which means that we have a reduced number of rows coming out of that scan. So cool stuff there, right? We got to see that the insert to the table variable was serial. We got to see that we could read from the table variable here in parallel. And we kind of got to see how the estimates that you get from table variables are bad and often influence the optimizer away from a parallel plan because the cost of a one row query is often so cheap that SQL Server just doesn't, you don't break cost threshold for parallelism there. SQL Server doesn't get an expensive enough cost estimate in order to start thinking about parallel plans. So now let's take everything that we just did here, and let's take this query and let's stick it inside of a multi-statement table valued function, because that is sort of the point of this whole thing. So we're going to take all of that same logic and we're going to put it inside a function, and now we're going to call a query, or call that function in a query. And so sometimes I don't know where some of this comes from. Some of this formatting just plops in and it looks weird, and I spend a lot of time fixing it. I have SQL prompt too. I don't know what happens. It's bizarre. Absolutely bizarre. So I'll run this. You can see I have SQL prompt. It's right here. Before anyone says, "This is SQL prompt," I have SQL prompt. Stuff gets weird. So this query ran for 4 seconds, which is about what we would expect, because that's what happened when we ran that same query just without the function. But I want to show you a couple interesting things. One is that despite having this hint here to use a parallel plan, we do not read from the table variable in the multi-statement table valued function in parallel. There is no parallelism icon here, and the operator immediately following the scan is a distribute streams, meaning SQL Server needed to take one thread and split it up into multiple threads with rows across. So if we look at this, we now have 4 threads and we have all that there. If we look at this, we have all rows on a single thread. So we took single thread and split it up into 4 threads and distributed rows pretty evenly across them. This is another limitation of multi-statement table valued functions. You cannot read from the table variable inside of a multi-statement table valued function in parallel. If you don't have a lot of rows in here, that's probably not a big deal. If you do have a lot of rows in here, which some people will undoubtedly have, because I've seen people putting tens of millions of rows in table variables and not being sure why things are slow. But, that's just me. That's just the kind of stuff that I get called for. The other thing that's really interesting about this is that the time disappears. We know this runs for 4 seconds. If we get the properties of this select operator and we go to query time stats, we can see that we spent 4.6 seconds of wall clock time running this query. But the operators in the plan don't come anywhere near adding up to that. By the time we get to this final sequence operator, we're at 147 milliseconds. One might wager that the majority of the time was spent in here, and that it's just hiding from us. The time was not spent returning rows. If it was just time spent returning rows, then we wouldn't have it wouldn't be in the elapsed time here. But we can probably guess that remember up before when we ran this and it took about 3.5 seconds and the whole thing took about 4 seconds total, and about 3.5 seconds was inserting into the table variable. Well, I'm pretty sure that between you and I, we can make a reasonable guess that that's what took 3.5 seconds in our plan there. It was doing all that. Good times, right? Good times. Good times with functions. Anyway, that's all I had to say about multi-statement table valued functions. Be careful with them because they do use table variables. Table variables have a lot of performance or potential performance hiccups in them. So please be judicious and test carefully if you're going to use a multi-statement table valued function. Maybe try to separate it out from big important parts of code as much as possible. Something like that. I don't know. Whatever. Anyway, thank you for watching, and I will see you in yet another video. Goodbye.